Let us see a cloud experiment for fire alarm using fire sensor, RGB and buzzer. Fire sensor is an input. RGB and buzzer is output. The flowchart explains powering the fire sensor to 3.3 volts, 3.3 volts to the RGB which is already powered in the board and buzzer to the 5 volts to the ESP32. And 5 volts to the ESP32 in another kit which is already powered. Now connecting the fire sensor to ESP32 as input in one IoT kit and output to the RGB and buzzer from ESP32 in another kit. Include Wi-Fi, Arduino, Arduino JSON, PubSub client for publish and subscribe, and Wi-Fi manager to fetch from the library. Define Thermistor in any digital pin, here we assign with GPIO36. Initially we assign string for my MAC address and set publish topic. Now inside the void setup we begin the serial monitoring function to set the baud rate. Wi-Fi.MAC address function is used here to store in any variable. Here we use my MAC address. Write serial print function, to display the my MAC address value in serial monitoring. Use call function to connect with Wi-Fi. Assign the pin mode function for the input to the Thermistor. Next we write the function for cloud using MQTT. Similarly, enter your MQTT server ID and port. Now we get the declared my MAC address value in client ID using string function. Using while loop we verify the client ID is connected or not. If the attempt fails to connect with MQTT we write function to reattempt to connect with the MQTT and serial print as try again in 5 seconds. Inside void loop, we write the command to check the Wi-Fi connection. If MQTT is connected, it calls the fire sensor function. Else it reconnects the Wi-Fi. Now we code for fire sensor function. If Thermistor is low, MQTT will pass the value as 1. Or its high value as 0 to the client. Now we write the code for connecting with Wi-Fi. Wi-Fi mode function is used to connect with the STA like a hotspot. Using if condition, if Wi-Fi is connected, serial monitor print is connected to Wi-Fi network with IP. Else serial monitor print as cannot connect to the network. If the result is true with the username and password, it is connected with MQTT, else failed to connect with MQTT. Now save the file, verify the program and upload in ESP32. Similarly, include the header files and define the RGB and buzzer pin GPIO 16, 13, 12 and 14. Subscribe the topic which we have published in the fire sensor. Now we write the code in void setup. Similarly, we begin the serial monitoring function to set the baud rate. Wi-Fi.MAC address function is used here to store in any variable. Write serial print function to display the my MAC address value in serial monitoring. Use callback function to receive the key value from the published value. And assign the value to the temporary variable. And check the value. If it is 1, buzzer will be activated and call the RGB red function, else buzzer will not be activated and call the RGB green function. Connecting with the Wi-Fi and MQTT protocols are similar to the program written for the touch switch. Here the circuit diagram shows the actual wire connections being used. Connect the selected input, that is fire sensor, to the 3.3 volts power pin and the input pin to the GPIO36 pin for fire sensor in one kit. Connect the selected output buzzer to the 5 volts pin, IP pin to the GPIO16 pin, and RGB LED to the 3.3 volts pin which is already powered in the board, GPIO to 13, 12, 14 in another IoT kit. Power both the IoT kit by connecting the adapter. Now heat the thermistor for the alarm function in buzzer and RGB LED indication in the another kit. A fire sensor is a detector which is mainly designed for detecting as well as responding to the occurrence of a fire. Fire sensors are used in different places like hydrogen stations, industrial heating, fire detection, fire alarm, industrial gas turbines and more. RGB LED is combination of three colors like red, green and blue in just one. RGB commonly used for lighting indication by respective colors, it's used in industrial applications for identify the state of controls and logics, sign boards and digital displays. A buzzer is an audio signaling device, which may be mechanical or electromechanical. Typical uses of buzzers include alarm devices, timers, machineries and automobiles.